Hey, D. Dykstra here, again with another great math video to help you in your journey through the mathematics that we love so much. All right, so here we're talking about rational zero theorem. So rational zero theorem involves a lot of using synthetic division, finding factors of numbers, etc. So, why do we use the rational zero theorem? Well, let's say I'm trying to graph a polynomial, and for some reason that polynomial either won't factor by grouping, there's no GCF, there's no greatest common factor to get out. So now I have to create some list of values where I can determine what the zeros are. And so this theorem helps us find all the possible zeros that we might have and then utilize them. And then, and not in this video, but in the next video, what I'll do is I'll show you how to use Descartes' rule of signs, where we can narrow down some of the values in terms of what the zeros might be. So let's see. Why do we use it? When factoring becomes challenging. I mean, basic. That's what we're after, right? We have to figure out how can we do this now. We don't want to. We don't have the tools yet. So we have a new tool, and it's called the rational zero theorem. So how do we use it? Well, we take the factors of the constant term, right? We call those the Q values. And then the factors of the leading coefficient, we'll call those the P values. And maybe back in my day, we used to call this the PQ test. And so now it's a kind of tradition that we do that. In other videos, you might just call it the factors of the constant term divided by the leading coefficient terms, or some other fun name for it, but call it the PQ test here. Anyway, P is the value of the leading coefficient, where n is the highest value of the exponential in the term, plus some other terms with exponents that are all lower than this nth value. We go n minus 1, n minus 2, etc. until we finally get to that constant term, just q. There is no x associated with that. And so what we do next is we create a list of all the possible zeros. And in doing so, after we find the factors of the constant term and the factors of the leading term, we create that list. Then we make sure to use all the numerators and denominators. Sometimes we get these factors in this leading coefficient, and they might be 1, 2, 3, etc. And so we need to make sure we use all those, and we might get fractions as some options as well. We'll see that in one of these exercises. Finally, we use synthetic division to verify the options that we've found. Okay, so here we've got the function x cubed plus 2x squared minus 5x minus 6. So what I did was I went ahead and put a big box around my leading term, and hence my leading coefficient would be 1, right? You don't see it there, but it's there. And then the last term, or the constant term, is negative 6. So if our Q value is negative 6, right, negative 6, right, from that, then what are the factors of 6? Well, plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6, right? Those are the factors of 6. Then I look and say, well, what's the P value? The P is up here. Well, again, I said that is a 1, and so what are the factors of 1? And we get that from that term, okay? So those are the two terms I'm looking for. What are the numerical values associated with it? And we notice that the factors of 1 are just plus and minus 1. Now, we always put plus and minus because, remember, I could have positive 2 and negative 3 and create negative 6. I could have negative 6 and a positive 1 to create a negative 6. So we always include the plus and the minus options for those. Hence, list of possible zeros. In this case, it's 1 over 1, 2 over 1, 3 over 1, 6 over 1. And in this situation, it's easy to see how that comes about. In the next example, we'll show you, we'll get some fractions. All right, So now we have to use synthetic division to verify. All right, so let's check out the synthetic division piece. Synthetic division, remember, we place the coefficients, the leading coefficients, in this bucket type system, if you will. 2, -5, and -6. And those are from here, there. And if you need more help, you can go to the video on synthetic division to help you with that process a little bit more. Now what I do is I just choose some numbers from this list. I typically tend to start with negatives, but I want to figure out, well, if I have a negative here, I have a negative here, something multiplied by a negative will create a positive, and I really want a positive 6. And this negative also tells me that if I multiply by another negative, I'll probably get a positive. So that's why I started with -1. And so we bring our 1 down. -1 times 1 is -1. We add these two numbers together. 2 plus -1 is a positive 1. -1 times 1 is, again, -1. And -5 plus a -1 is a -6. And now when I multiply that by -1, I get a 0. I get positive 6, which when I add, I get a 0. And what that 0 tells me is that, yes, -1 is a 0 of the function. So now, since this was a cubic, I reduce it, and now it becomes an x squared plus x minus 6. And all I'm using here are the coefficients. I mean, this 1 is right there. That's 1x squared from that one. This 1 drops down, becomes a 1 there. And now I can just look at it and say, oh, I can factor. That's a quadratic. That's x plus 3 times x minus 2. What two numbers add to positive 1 and multiply to -6? And that are the options. So our final factors are x plus 1. Now I got that from here. Remember, this is what the x value is. So the factor is when I take this x equals -1 and add 1 to both sides. I get x plus 1 here. And then we found out that it was x plus 3 and x minus 2. So our final zeros in this case are x equal -1, -3, and 2. All right, next option here we have is we've got 2x cubed minus 3x squared minus 11x plus 6. Okay, so when we develop our PQ test, again, Q goes on top. They are the factors of 6. We've found those once before, but let's go through them again. Plus and minus 1, 2, 3, and 6. Now, in this case, I didn't write down all the plus and minus. It's kind of understood that you use plus and minus, so we don't necessarily have to write them down all the time. In your notation, your professor or teacher might want you to do that, but certainly it's fairly understood that each are going to be plus and minus. Now, we look at the P, and this is the leading coefficient, and I notice that that's a 2. So I'm going to take the factors of 1 and 2 are the factors of 2. Now, when I go generate my list, again, I'm going to put 1 over 1, 2 over 1, 3 over 1, and 6 over 1. That's where I get that list from, 1, 2, 3, and 6. But now watch what happens when I use the 2 as the denominator. Remember, one of the goals was to make sure that we use all numerators and all denominators. So, in this case, if I put 1 over 2, that gives me a 1/2. All right? 2 over 2, well, 2 over 2 is just 1, right? That's already back over here. So I've already included that as a factor. 3 over 2, well, I don't have 3 over 2 yet, so I'm going to put that in my list, right? And then 6 over 2, well, what's 6 divided by 2? That's just 3, and I have that there. So then my list is complete, all right? So now what we're going to do is we have to use the method of synthetic division. So we notice we list all the coefficients, okay? 2, -3, -11, and 6. And what I chose to start with here was -2. And in this case, because I've got a 2 and a 6, I figured, well, 1s may not make it, even though we might find that it does. But I started with the next big negative number. Whole numbers usually where I start, and hoping that something times -2 might be big enough to where I'm going to get something to subtract and create a multiple of 6, which is 2, and so forth. So let's just walk through it. Again, you bring down your 2. -2 times 2 is -4. I add -3 plus -4 is -7. Then -7 times -2 is +14. -11 plus 14 is +3. When I take -2 times 3, it's -6, and I get a 0. Which leads me to 2, -7, +3. Now I could use factoring by X method or something like that, but what I'm going to do is I'm going to go ahead and try synthetic division again. And so if I use synthetic division again, then I can do that. Well, I'm going to switch gears maybe, and I know I have a 3 here, so 7, what would I have to multiply to a 7 to get a number that would then be a -3? So I'm going to try a +1/2. So a +1/2. All right, so what I'll do, again, is I bring down the 2. Bring down the 2. And so we get 2 here. And I'll take 1/2 times 2 is +1. Right? Now, -7 plus 1 is -6. I take 1/2 times -6. Oh, look, I get -3 and I get a 0. There. So I know that now I've got -2, I've got a +1/2, and then I get 2x minus 6 equals 0. So what I'll do is I'll set 2x minus 6, set that equal to 0, and we notice that x is equal to +3. All right, so my final factors are x plus 2, right? I took that from here. The x value is -2, so the factor is +2. X minus 1/2. And my other factor, x, was 3, so I get x minus 3. Those are my 3 factors. And now I have to look at what are the final zeros. Well, we found them. -2, 1/2, and 3. So x is equal to -2, comma, 1/2, comma, and 3. And there we go. All right, so that has been rational zero theorem using the PQ test. I hope you have enjoyed that. Thanks again for watching, and check out more videos to come on other function mathematical great things. All right, thanks. Peace. Have a great day.